All right, so now we're going to talk about a very special type of discrete random probability distribution, or discrete random variable, which is the binomial distribution. So a binomial distribution is a discrete random variable, but there are 4 specific requirements that must be met for it to be a binomial. These 4 requirements are, first, a fixed number of trials. Meaning, if you're going to do something like roll a die, you have to decide, I'm going to roll a die 20 times before you start. You cannot say later, you know what, I think I'm going to do 5 more rolls. Or you also cannot say, I'm going to keep rolling until I get a 2. Because you could see a 2 on the first roll. It could take you 20 rolls to see the 2. It could take you 100. Probably won't take you 100 rolls to get a 2, but it could. So you have to decide before you start how many times you are going to perform the experiment, how many trials you are going to have. The second requirement for a binomial is that the trials are independent trials, meaning the outcome of one trial does not affect or give us any information about the result of the next trial. So rolling a die, each time we roll a die, that is an independent trial. Each time we flip a coin, those are independent trials. If we randomly choose people from a population, those people are independent of one another because they were chosen randomly. The third thing we need to have for a binomial is only 2 possible outcomes. So my previous example of rolling a die doesn't necessarily work because there are 6 possible outcomes when we roll a die. Flipping a coin, however, does work because there are only 2 possible outcomes. You can have heads or you can have tails. We refer to these outcomes as a success, meaning whatever it is that we are interested in, the outcome of interest, and a failure, which is whatever the other outcome is, the one that we are not interested in. So if I'm flipping a coin and I want to know how many times I get tails, the success would be that the coin lands on tails. A failure would be that it landed on heads. And then the last thing is that the probability of a success is the same for each trial. Now that kind of goes along with the trials being independent of one another. Typically, if you have independent trials, the probability of a successful outcome will be the same, but there are some specific times where you might not have independent trials, so the probability of success does stay the same, or vice versa. So we just want to make sure that we're looking at things where the probability of success is stated as being the same. So these are the 4 requirements that we must meet for a discrete probability distribution to be considered this special case